Hi there, I'm Juan, and today I will show you how to inspect the inside of medical plastic parts. For medical plastics, we often have the difficulty of measuring translucent or transparent materials like this bottle drop. You will also notice we can take a scan of this bottle and dropper assembled. No need to scan the parts individually. What better way to scan a part like this than with the ZEISS METROTOM 1? By using a scanner that acquires data via X-ray images, we can not only disregard the difficulty of the transparent materials, but we can also measure internal and unseen surfaces. To get started, I will take a quick scan of our assembled bottle with the METROTOM 1. Now that we have completed the scan, I can show you how to make a few key inspections on this bottle assembly. As I mentioned before, the strength of the METROTOM 1 is that it allows us to capture 100% of our part geometry inside and out. To have an initial look at our internal geometries, let's first make a clipping plane down the middle of the part to make the unseen seen. From here, we can check the material thickness of our bottle, since we have all internal surfaces. We can do this with only a few clicks via Eye Inspect. From here, two inspections have been created. First is the material thickness of the CAD model. The second inspection is the material thickness of the part itself. Let's take a look at the difference between the two inspections. We do that by using the material thickness deviation inspection via Eye Inspect. From here, we can adjust our legend to get some key insights on our material thickness deviations. We can see immediately from the color map that we have some excess material thickness around the neck of the bottle, as well as the very bottom of the bottle. If we adjust the legend further, we can see that the bottle also becomes thinner towards the bottom of the bottle on the outer wall. With these insights, manufacturing engineers can optimize manufacturing parameters to get closer to design intent than ever. Next, I would like to show you how to evaluate tiny and unseen geometries on a medical plastic part like this. For this example, let's turn to the dropper piece at the tip of the assembly. We already had a look at the STL surface data with the material thickness analysis. For this inspection, let's start with the CT volume data itself. Since it is a rotationally symmetric part, let's change our screen layout to the rotational view. From here, we can align the parts such that we get a cross-section looking down on the piece, as well as a rotational axis to look at the nozzle in 360 degrees. From here, we can do a few visual checks. The first thing I would like to check for is that nothing is blocking the channel so that liquids can exit the bottom. This one looks clear. The second thing we can look for are any irregularities in general. On this part, I notice here a dent or lack of symmetry around the interior of the nozzle. This raises a red flag for me to check with the design team to see if this could cause any functional issues with the part. The last thing I would check for is a proper seal between the nozzle piece and the main body of the bottle. We can create live videos within the software to do this type of inspection visually. Now that we have done a few visual checks on this part, I will show you how to take a few measurements on this crucial area of the assembly. If we turn back to our STL digital twin and take a clipping plane down the middle once more, this will give us easy access to the internal geometries we are interested in. Most of these crucial features are cone geometries. Let's quickly fit some cones using the function construct cone. With a few clicks, we have multiple cones fitted to our nozzle, channel, and opening. From here, we can easily inspect all angles at once using the angle check via Eye Inspect. From here, there are so many other inspections we could pursue, such as the angle between the center lines of these cones, the diameter of the nozzle opening, or even the surface profile of the threads on our bottle and color. This completes the how-to. For more how-tos, getting started, product updates, or any other question regarding 3D scanning, please visit handsofmetrology.com. You will find a link in the information section of this video. Thanks for watching and see you next time.